Hey everybody, welcome to the next video. This is Mr. Salmingo. I know it's your 3-day weekend, but I wanted to do a quick lecture so we can get to doing some activities when we get back to class. As you can see, I have a little buddy to help me out with my video. Some of you asked if we could have him in the video. He's sleeping now, so sorry if he's a little bit of a distraction, but here's the baby. Alright. I might have not asked you guys to bring your notes home, so if you don't have your notes, maybe you can write it down on a blank sheet of paper, but for the most part, a lot of people said they never heard of Sohcahtoa before in their history of math, so we're going to go over this so that you understand it. So, the reason why there's such thing as Sohcahtoa is that there's a special relationship, sine, cosine, and tangent, that is equivalent no matter how big a triangle is, how small a triangle is. These ratios tend to be exactly the same, just as amazing as pi was. So you see this degree right here. So anytime you have, it has to happen when you have a right triangle. This means that it's 90 degrees. And no matter where the angle is, the one across from the angle, the one where the angle opens up to, they term that opposite. The one that's next to it, they term that adjacent. And the longest side, the side across from the 90-degree angle, they call that the hypotenuse. So here's the three relationships you need to know. Sine is equivalent to opposite over adjacent, okay? Which means, opposite over hypotenuse, so like the part that says so, sine equals opposite over hypotenuse. Cosine, cosine equals adjacent over hypotenuse. And tangent, toa, is opposite over adjacent. So these ratios, again, no matter how big the triangle is, as long as you have that same angle, you could find out or see how long the other sides of the angles are. The other three that you need to know that we've practiced a little bit, cosecant, secant, and cotangent. To make it simple, I'm just telling you to just flip its partner. Cosecant and sine are partners, so whatever sine is, just flip it. Whatever cosine is, just flip it and you get secant. Whatever tangent is, just flip it and you get cotangent. So let's see a couple examples of how to find these trig functions. So here's a nice, pretty triangle. I know I could use Sohcahtoa because I have a 90-degree angle, so I have a perfect right triangle, but do you see how I'm missing an angle? Yeah? So what I'm going to do is I need to first solve for the missing angle. You guys remember Pythagorean theorem. So 12 squared plus the side squared, which we have no idea what it is, equals the same thing as the hypotenuse squared, which gives me 144 and 225. Oops, 225. To get x by itself, I'm going to subtract 144 from both sides, which gives me 81. And you know what number squared gives me 81? That's 9. So now I found all three lengths of the triangle. So what I'm going to do, I'll type this out. It might be easier to read. So let's do sine first. Okay. Sine, if you remember, is the opposite over the hypotenuse, or so, S-O-H. So sine of theta, here, I'll write funky theta. Sorry, don't think of that as 0. Think of it as sine theta is equal to 9 over 15. And now that you're a little bit more comfortable with trig, I'm going to ask you to reduce. So sine of theta is the same thing as 3 over 5. Cosine of theta, ca, is adjacent over hypotenuse. Do you see with my angle here, the adjacent one is this one here, 12. It's right next to the angle. And the hypotenuse is still 15, so 12 over 15. Or reduced is 4 over 5. Then tangent, the toa, tangent of theta, is opposite over adjacent, so it's opposite of theta, the one that's opposite, or the one that opens to, is 9. Adjacent, the one next to it, is 12, so 9 over 12, or 3/4. So you're okay with sine, cosine, and tangent? Yeah? Not so bad. Okay, not so bad. Now, the next thing you're going to do is you're going to do the partners. Remember the partner of sine is cosecant? So what I do is just flip the answer that I got for sine. So you see for sine how I got 3/5? So the answer for cosecant is just 5/3. So I want to figure out secant of theta. I just flip cosine, so I get 5 over 4. And if I want cotangent, all I have to do is flip tangent, which was 3/4, so now cotangent will be 5/3. So that's as much as you have to do in terms of finding out the trig functions. Alright, letter B. Letter B says same thing, but I'm missing, again, another angle. So what I'm going to do first is I need to find that angle. X squared, that missing leg, plus the other leg squared, is equal to the hypotenuse squared, which gives me x squared plus 25 equals 36. To get x by itself, I'm going to subtract 25 from both sides. This gives me 11. Some of you don't know what the square root, what number squared gives me 11. But I could just leave it like that. I'll square root both sides. I get the square root of 11. So this side is square root of 11. So you're saying, oh, that's ugly. It's not pretty. It isn't an exact number, but it's still a number. So again, I'll put it here. I'll do the 3 trig functions. So I'll do sine theta first. Sine is opposite over hypotenuse. Remember, so opposite of my theta is 5, and my hypotenuse across from my angle is 6. Okay. Cosine of theta is the one adjacent over hypotenuse, or Sohcahtoa, adjacent over hypotenuse. So I don't have a square root. I'm just going to use this little slash. Square root of 11 over 6. Does that make sense? So square root of 11 over 6. And then tangent theta, toa, is I take opposite over adjacent. So opposite of theta is 5, adjacent is square root of 11. Again, I told you that, so that's 5 over the square root of 11. I told you that now that we're practicing enough, now I want you to start reducing. So you're not allowed to have a square root of 11 on the bottom. So what I'll do, if you forgot how to do that, we did actually at the beginning of the year, I'll remind you how to do it. I'll put it up here. 5 over the square root of 11. To reduce it, or to get this radical over top, I'm going to multiply top and bottom by square root of 11. So this reduced, or simplified, is 5 square root of 11 over 11. Oops. 5 square root of 11 over 11. So tangent is 5 square root of 11 over 11. Alright. Now, back to the other 3. Remember, if you know these ones, the other 3 are very simple. Cosecant is just sine flipped, so 6 over 5. Secant is just cosine flipped, so 6 over the square root of 11. Now here's the problem. I can't leave square root on the bottom. Some of you will remember how to do this. So it's supposed to be 6 over the square root of 11. Or if I multiply top and bottom by the square root of 11, I'm going to get 6 square root of 11. And I'm bleeding onto here. 6 square root over 11. 6 square root of 11. How about this? Over 11. Okay. So 6 square root of 11 over 11. That's how it simplifies here. I'll draw a little fraction bar for you guys, and oh my gosh. This thing's taking a mind of its own. Let me just move this to the side. You don't need that anymore. Hold on, I can't move this. Oh well. And then, I know, sorry. And then cotangent, again, is tangent flipped. Now here's the tricky part. Remember when we did tangent, we got 5 square root of 11 over 11? Well, I could re-flip that and re-simplify it, but remember initially, when we first did this, we had 5 over square root of 11? So really, cotangent, you already know, is going to be, here, I'll draw it out for you, it's just going to be square root of 11. I don't know why it's doing this. Square root of 11. Square root of 11 over 5. And the reason why is because, just to repeat, remember tangent initially got 5 over square root of 11. So if I flip that one, I'll get square root over 5. If I flip the simplified version, it requires more work. So just know, be smart about it. You already knew this was, and if I flip it, I know I don't have to simplify it. Special triangles, I'm pretty sure I know you've seen them all. It's also on the SAT, so this shouldn't be new to you. It's just saying that every time you have a 45-degree or a 30-degree or 60-degree angle, they all have a very similar ratio. So for example, if I have they call this an isosceles triangle, where the angles are the same, and I have a 90-degree angle. But they're saying that the ratio is these legs have to be equal to each other, and the hypotenuse becomes the square root of 2. Or if I have a 30, 60, 90 triangle, again, the one across from 30 is always 1, the one hypotenuse is always 2, and then the one that's across from 60 is always square root of 3. So we'll see how you could use those, and actually that's part of the experiment that I want you to do. I know that you guys have seen this. I actually helped you guys if you had a previous class, like use a given value to find the remaining trig functions. So it says sine of 60 is square root of 3 over 2. Well, first thing I'm going to do is I'm going to draw it. So here's 60. Here's my square root. Here's 30. And if it says sine of 60 is radical 3 over 2, that tells me that opposite, remember Sohcahtoa, opposite over hypotenuse, is radical 3. And this is 2. You could use Pythagorean theorem to find this last piece. You also know that's a special triangle. You can look up at the other part of your notes. But you'll know that this is 1. So now to find the remaining trig functions, it's very simple. All I'm going to do is do Sohcahtoa. Sine of theta is going to be, I'm going to find the remaining functions. So sine, we're all doing 60. So we did sine of 60, cosine of 60. So adjacent to 60 is 1. Hypotenuse is 2. So cosine of 60 is 1/2. Tangent of 60 is opposite over adjacent, just like TOA. So opposite over adjacent, radical 3 over 1, or radical 3 over 1 is just radical 3. So now the easy parts, you just flip the rest of them. Cosecant of 60, I flip radical 3 over 2. You'll notice when I flip it, I get 2 over radical 3, which is no good because I have a radical on the bottom. So do you know what I multiply top and bottom by? Yeah, multiply top and bottom by 3. Radical 3, sorry. So simplified, it's 2 radical 3 over 3. So cosecant 60 is 2 radical 3 over 3. And I'll just put an arrow there. Alright. Secant, remember secant of 60 is just flipping cosine. Cosine is 1/2. So flipping it, I get 2. And then cotangent is just flipping tangent, which was radical 3. If I flip radical 3, I'm going to get 1 over radical 3, which again is no good because I have a square on the bottom. So I'll multiply top and bottom by radical 3. And when you do that, radical 3 times 1 on top, I get radical 3 over 3. And I'll just write an arrow for that too. So that is Sohcahtoa. We'll practice a little bit more in class. I'm already at 13 minutes in the video, so hopefully this review helped you understand Sohcahtoa, and we will practice a little bit more when I see you guys on Tuesday. Remember, because you told me to remind you on the video, to bring a piece of cardboard. If you could bring some extra, because I know people are going to forget, so I can give you some extra credit. And I'll see you guys. Enjoy your 3-day weekend. It's not my goal to give you homework, but I want you guys to relax and be rested and be safe. So be good, take care. I'll see you guys on Tuesday.